Today we are studying Tandem Accelerator. What is Tandem Accelerator? So Tandem Accelerator is actually a two-stage accelerator. So it is a modified form of Van de Graaff accelerator. So here's the question. So what is tandem accelerator? Tandem accelerator, it is so since we know that the Van de Graaff accelerator is a single phase accelerator, but tandem accelerator is a modified form of Van de Graaff accelerator. So in tandem accelerator, there is the two-stage accelerator. We can obtain the obtained charge particles in energy double that of the Van de Graaff accelerator with the same operating voltage. Since the principle of the tandem accelerator is that in a single stage accelerator, positive ions are produced at high potential. So in a single stage accelerator, which is Van de Graaff accelerator, the positive ions are produced at high potential. Then these are accelerated from high voltage to the ground potential. Okay, so these are accelerated. These positive ions are accelerated from high voltage to the ground potential. In case of the tandem accelerator, which is a two-stage accelerator, the negative ions. So the negative ions in the first stage are produced at the ground potential. Okay, so the first stage, the ground potential ions are produced at the ground potential. The negative ions are produced. Okay, so and they get accelerated towards the high positive voltage. So that is the main difference. Next is in second stage, the electrons are stripped off and the negative ions are changed into positive ions, which are then accelerated again to the ground potential. Okay, we'll see it in the diagram is over there also. So these positive charges are over here in the first stage. In the second stage, these turn negative, and these are the charged particles. Negative ions are then changed into positive ions. So here the negative ions are then again transferred into the positive ions, which are then accelerated again to the ground potential. Got it? So this is ground potential. This is ground potential. So the positive ions over here. So see the ion sources over here. So the positive ions flow from that in the stage 1, and then they turn into the negative ions at the ground potential. Then they are accelerated. They are changed into positive ions. Then they are again accelerated to the ground potential. So next thing is that changed into the since we have done that, then accelerated again to the ground potential. In this way, the energy of the charged particles can be increased with the same operating voltage. So see, with the same operating voltage, we can increase the energy of the charged particles. So what is the construction? So here I have made a new diagram for you guys. So this is that the construction is so easy. I'll let you guys know. Here's the charging belt. Okay, so this is that the construction of the tandem accelerator is shown here. It consists of a source of positively charged ion, which is known as S1. So this is known as S1. It is a source of positive charge ion. So see, it is a source of only positive charge ions. So positive charge ions are coming out of here. So the ions are passed through column C1. Ions are passed through column C1 over here, which add electron to these column C1 add electron to these positive ions. See, so very small fraction of positive ions is converted into negative ions in the column C1. So here's the column C1. So very small fraction of these are converted into the negative ions in column C1. A beam of positive and the negative and the neutral particles which comes out of C1 is passed through a magnetic field. So here a beam of positive ions and negative ions as well as the neutral ions will come out of C1. It will pass through the magnetic field over here. So here it is represented by M1 and it is magnetic field. Got it? So the next thing is it is provided by the magnetic M1. So here is the magnet M1 which produces a magnetic field, and they are passed through this magnetic field, and it separates the negative ions from the unwanted particles. Since these negative ions are attracted towards the positive terminal T. So here's one positive terminal T, which is high positive terminal. So these negative ions are attracted towards it. Okay. So next we can say that these negative ions are attracted towards the positive T1 through an insulating column. So here is an insulator, or we can say that it's an insulating column. Yeah, it's TOR, column. So next thing is that the beam of negative ions is therefore accelerated. So these negative ions are accelerated towards it. So they are accelerated at very high velocity because of there is a great deal of potential difference. So this accelerated beam of negative ions is then passed through the stripping canal C2. Since here is a stripping canal C2. Okay, so they are passed through it, and it contains this canal contains a gas at the low pressure, and it removes the extra electrons and change each negative ion into positive ion. Okay, so in this case, gas is given by the source S of the proton. The column adds C1. So the column is that it changes the negative ion into positive ions. Okay, current at C1, and C2 removes the two electrons from each negative ion and put them back into the protons. Change them back into the protons. Got it? So the beam of the positive ions produced by the stripping canal is repelled by the positive terminal. At the ground potential, it is again accelerated. So here's the ground potential again. So they are accelerated again. It should be noted that the second stage is extremely powerful when the heavy ions are accelerated. For example, take the case of oxygen nuclei with the atomic number of Z8. So if we take an example of oxygen with the Z is equals to 8. So here's the voltage terminal is 5. Voltage terminal is so big. So here's the diagram. You have seen that it changes, C2 changes from negative to positive. It is the charging belt. Got it? That is the diagram, and that is the principle and construction and working of the tandem accelerator.